All right, welcome DS12 to our very first Q&A session. These sessions are optional, so the fact that we don't have anybody here, everybody here rather, is okay. We're going to go for up to an hour. So we've got a Slido thread open for any questions that you have. I'll try and get to as many of them as I can. We'll start off with the most upvoted questions / the questions that are kind of technical and relevant to the last couple of modules that we'll be looking at. And then if you want to add any questions that are kind of less technical, I'll get to those as we have time. All right. So
my questions are better spoken than typed, I think. Like for when addressing something technical in pandas or Python or whatever.
Yeah. So you can just start like the general topic there. Say, hey, I want to talk about XYZ, so other people can upvote it. And then when we're in these Q&As, we're less strict about like unmuting yourself to speak. So if you want to give more context when we get to that question, verbally unmute yourself, that's totally cool too.
Okay, so I see the format you're working. Okay.
Awesome. All right, I'm going to share my screen and we'll take a look at what is on Slido. All right, why when importing the data set of loans during the first lecture, on the first time, the first two columns do not show as nans all the way down. Sorry, just during the lecture, just the first row. When we erase the first row, it changes. So let's take a look at that. What I'm going to do actually is I'm going to start a new Google Colab document that we're going to use just for all of our brainstormings here. So here are the lecture notes that I'll look at just to get caught back up with what we were doing. And here's the Colab I'll use during this Q&A, so that it's kind of a little bit differentiated from what we did during lecture. My goodness, come on tabs. And we'll call this Sprint 1 Tuesday Q&A DS12. And I'll share this link here in Slack in case you want to access this later. All right, so asking about what happened to all the nans in the first column, right? So let's go ahead and we'll wget our file again. Scroll up in my notes to grab the link here. One thing that's maybe fun about Q&As is you'll see me working less dependent on notes. So I'll have to look things up more often. During lecture, it probably looks like things are just, I have all this syntax memorized, and that is not the case. I have to look things up frequently. And so I think another important benefit of these Q&As is you see something that's closer to true live coding than during lecture. Lectures, I've taught the same things so many times that even if I didn't have notes, I would probably be able to write the code out a lot faster than I typically would if I was just working on my own. For example, I'm copying and pasting right now, right? All right, and here's the first time that we read in the CSV. All right, got the file, unzip the file. It's now in my notebook's memory, right there. And I'll read in the CSV and we'll look at the results, and I have not imported pandas. All right, so now referring back to the question it said, the first two columns do not show as nans all the way down, just the first row. When we erase it, the first row, it changes, right? So here's what's really happening. If I look at the head of this data set here, wait for it. Oh, I need to say head loan stats CSV. Stop. All right, so I canceled that command. Run it. So what's really happening is CSVs get read in starting from the top left, and each cell is assigned based on where read CSV sees comma values, right? So it looks at the very first line and it says, okay, where are the commas in this first line? It goes, oh, I don't see any commas. So this must be one cell, and this one cell must be the header for the whole data set, right? So what actually happens is it reads this first cell in and it goes, oh, this data set only has one column, right? Because there's no other commas to differentiate different files in here. So this must mean that everything else after this goes in the same column, right? So because of that, it's acting as if these NaN values are all together. I don't know if that makes a ton of sense, but basically, the short version of the answer is the way that read CSV parses through this file and looks for the header, looks for the commas of how to separate different columns. This first column is kind of turning everything into the header. Notice how everything here is bolded. It doesn't matter if I do df.head 20, show the first 20 rows. It's going to take it a minute, big file, right? Everything is bold. It thinks that everything in the whole data set is a header. Now, this header has a special kind of a name because you'll notice that this row goes all the way across. Can you see when I hover over this row, it's highlighted up all the way across? But that's different from this row. This row is lighted up with these NaNs and everywhere across, and this row's so-and-so, so on and so forth, right? What it thinks that this file is it thinks it's what's called a hierarchical index, meaning that I have multiple column headers, right? So here's the first row of column headers, and then I've got these subheaders, and then subheaders, 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 etc. Right? So basically, read CSV is just very, very confused. Hence, it is reading NaNs all the way down. That's probably the shortest answer I could give. Now let me address why it changes here, right? After I fix the first header, why does this get fixed, right? So let me copy this down to another cell. I'm actually just going to change this to just df.head the first 5 rows, so it's not quite as large of an output. Excuse me. And we'll say header equals 1. All right. So now what happened is when we said header equals 1, this then allowed the header to be set not based on this first cell, right? Now it skipped this first cell and said, okay, here's the header. So I know that this now is not a data set that has one single column. I know this is a data set with, what, 140 columns, right? And you can even see that here with the shape. It goes, this data set is one column. It's 128,400 rows and one column, right? See the confusion of read CSV there. Whereas here, it goes, okay, now I know that there's 144 different columns. So as I'm looking at these additional rows here, I go, okay, so this must be in column 1, this must be in column 2, this must be in column 3, etc. So it's able to break these blank cells into NaN values much more effectively. So you'll notice that read CSV by default, if it sees blank cells, we'll read them in as NaNs, right? So NaN is our typical missing value indicator. We have these blank quotation marks here. Read CSV is smart enough to turn those into NaNs for us. All right, so basically it's a problem of how the CSV file gets parsed, whether or not the read CSV thinks it's all in one single column, or based on us telling it where the headers are, it thinks there's 144 different columns, causes these NaNs to either be summarized over a whole column or to be broken out individually. You don't need to know a ton about this. You don't really need to understand to a large degree how CSVs parse through files, but if you want to practice, make yourself some really small, simple CSVs in a Google Sheet or something, and then download them to your machine and try reading them in with read CSV. You can try reading them in with varying levels of cleanliness or different issues with them, and see if you can figure out what what causes pandas read CSV to act in certain ways. So I hope that's helpful. I'm not going to archive things quite yet. Add a reply here, or you can just go ahead and unmute yourself if there's some more context I could give on this. Great. All right, so let's look at this. Can you explain the difference between int_rate and revel_util, different data types? Where are you seeing this revel_util at for our friends asking this question? Oh, these different columns of the data set, I guess. Let's take a look at it. What I'm going to do to take a look at this is we're going to take a subset of the data frame. I'm going to call that subset. I'm going to give it a list of column headers to grab. And where is revel_util? Right here. Oh, df subset.head. Then we just look at these two columns side by side. Okay. So to me, what this says, well, first off, they're not the same. They're not the same percentages, right? So there's something substantially different between the interest rate they're getting, and maybe this would be a different interest rate, and I assume this is like some revolving line of credit. What we can do is, well, we haven't really looked at like a .names file. We haven't looked at a data dictionary, right? Let me find you the data dictionary for this. So I think I have to log in. I don't even think I have a Lending Club password. Let's do this.
Do they just give away this data for nothing? Like, here, have data, people.
Yep, basically. So basically, they want you to come on and be a peer-to-peer lender, right? And if you have more data.
Oh, I see. It's peer-to-peer. I was thinking of like Lending Max or something like that.
Yeah, exactly. They're trying to entice more lenders by providing this data free and clear to us. I'm actually going to look at this. There's this Lending Club data on Kaggle. They send out the same data set every quarter, has the same column headers. And so Kaggle usually has similar data sets, but they usually have a good explanation of the different columns, right? So let's find that same column.
Think anyone will lend me some Bitcoin? And I'll flip that real quick.
What about Bitcoin?
I said, do you think anyone would lend me Bitcoin? I'll flip that real quick.
Depends how much. Depends how much.
Yeah.
Let's see if we can learn more about this, because I'm not 100% sure what that column is.
Revolving utility?
Lending Club data dictionary. Here we go. This is what I was looking for. But I want to, sure, I'll open it with numbers. Revolving line utilization rate, or the amount of credit the borrower is using relative to all available revolving credit. So it's like this is a much different percentage compared to their, very different from their interest rate. It's the amount of credit they're utilizing, right? So if you have a credit card that has a limit of $5,000 and you're using $2,000 of that, well, you're using 40% of your credit limit, which would make sense. Let's see if we see any values here that are greater than 100%.
Just for clarification, that statistic would be based on your yearly income and what your current debt rate is, like some variation of that, right?
I'm not 100% sure. I'm not sure if this this utilization percentage is referring to the usage of lending clubs loans, like your peer-to-peer loan, how much of that peer-to-peer loan line of credit are you using, or if it's referring to all credit that's been issued to you that's kind of on your account, so to speak, or if it's combining credit cards and home loans or what it's doing. But what I do want to check, actually this df.describe is not going to work. I wanted to look and see what the minimum and maximum values here were for this utility column. Why do you think that df.describe is not going to work on this column? Why did I just come to that realization? What do you think? Unmute yourself or type in DS12.
Probably in as a string, not numbers or floats.
Say that again.
Probably in as a string, or it's not in a float or number.
Yeah, exactly. It's not any kind of a numeric value. It's hard to get a minimum and a maximum value if it's not a number, right? So what I'm going to do is I'm going to clean this up really fast. And we're going to just clean this up exactly the same way we cleaned up interest rate during lecture. So I'm going to take those cell contents, strip off the leading white space, then I'm going to strip off the end percent sign, and then I'm going to cast it to a float. And then I'm going to say df subset revolving utility equals the same thing, but we're going to apply clean revel util to it, and then we're going to do df subset dot describe. I'll actually do that in a new cell. Okay, so clean up this column. Float has no attribute strip. What do you think's going on here? How come I got this error message?
Something's not being linked together, right? That's what I grasped from it. I'm probably wrong.
Okay, so what am I calling strip on? I'm calling strip on the cell contents. Strip is a function for strings, for removing characters from strings. So it's saying that at some point I'm getting some cell contents as my apply function loops over this column that has the data type of float. Why do you think that might be?
Because there's a float in your data at some point, and it's picking up on that, I would suppose.
Okay. There's a very specific float that I'm willing to bet money is what this is. Talked about it a little bit during lecture. And while you think about it, I'm going to add some type checking here. Yeah, I bet there's nans in this column. Should we check to see if there's nans?
Nan it up.
If I can type, never really can. There we go. I got 158 nans in this column. So I need to add a little bit of type checking. The int rate column didn't have any nans. Right?
Oh, this is the if cell statement. That's right.
Yep. So I'm going to say if is instance. So object and then the class. So if my cell contents is a string, then we'll return the operation that we want to do if it's a string. Otherwise, what should we return? I don't know, maybe just np.nan. Just leave it a nan, but it'll allow the function to actually work.
Why not use an if-else statement? What's the difference?
What do you mean? Because I am using an if-else statement right here.
No, I'm saying I'm saying like you used the if statement, then you go to return, but the else, why wouldn't it be if else? Like, I'm just wondering what conditions you would use if else in.
So I would add an if else statement if I had a third statement. So if it's a string, if else, or whatever it is. How do you do it in Python? I've been doing JavaScript recently. See something this basic? I gotta Google it. Elif, that's it.
Yeah, elif, sorry.
All right. So this is else if is what this is short for. Yeah, I want to check if the cell contents was an integer, right? So this is like a way I can chain multiple if statements. So if this, otherwise this, and then this final else is like the catch-all. If none of these above if statement conditions are met, we never get inside into these other if statements, then just do this at the end, no matter what, right? So that's kind of the main difference between, right, if versus else if versus else. I can have many, many elif statements here. And then just finish it off with an else statement. The else statement is just a catch-all. The if statement is the statement that I use to start the if statement. To let Python know that, hey, I'm going to go through a whole bunch of different conditions here and going to run some blocks of code if some of those conditions are met. But if none of these conditions are met, do this thing at the end. All right. So I'm actually going to remove this. And we're going to see if this will run. All right. A value is trying to be set on a copy of a slice from a data frame. I saw some discussion in the DS12 chat about this. What do you think is going on with this setting with copy warning? This is a really common warning to come up. A lot of people actually get really annoyed by it. And there's a group of Pandas users who wish this warning got removed from the library altogether. All right. All that this warning is really saying is, hey, you're changing parts of a column before you change other parts of a column, right? So you were trying to make changes to a copy of a slice of a data frame, a portion of a data frame, and it tells you to use a more specific method. Now, most of the time, we're pretty confident in what we're doing. We could just ignore this message. If I wanted to be really specific and make sure that I remove this, I would make what's called a deep copy of my data frame for before I started, and then I believe this should clean it up. But I've got to change some of these things here now. Right. Then there's no warning. All right. So this is a simple way of getting rid of the warning. Honestly, the warning is not mission critical. You could just ignore it. It basically means Pandas is trying to keep you from accidentally changing part of a column without changing the rest of the column, right? Because our apply function is going cell by cell. It's making changes to the column one little piece at a time. Pandas says, oh, that's dangerous because what if it crashes in the middle and you only end up changing half of the column, and then you've got problems. So it's trying to keep us from making that mistake. But largely, we won't need to worry about it. And over time, we'll get better at just doing things in a way that don't trigger that warning. All right, but let's do a df.describe, which is what we were after. At this point, the max is 183. So somebody out there is using 183% of their credit limit. I don't know how that's possible, but that's the largest percent out there. And probably a few people who are using 0 as well. If we want to get really into the weeds here, we can make a histogram to kind of analyze the whole distribution here. We can increase the number of bins, right? And you can see that basically nobody is using more than 100% of their credit limit, right? Kind of has this kind of a distribution. So somebody who has 183%, that might even just be a clerical error or something like that. I'm not a finance person necessarily, so maybe there's some cases where that's possible, but probably some loophole or corner case. So they're both percent columns, but they just represent very different things. Is the short story, but I did want to practice doing some of this cleanup, doing .describe, making histogram, lots of things we've been talking about the next couple of days, which help us further investigate this question.
I have a quick question about the cleanup that you just did.
Mm-hmm.
So I thought that all of the values in one column have to be the same type. So why do we have the nan and the string value in one column? Like, why does it let us do that?
Yeah, that's a very good question. So Pandas tries its best to keep all of the same type of data in one column, but it doesn't always do it. So instances where it can keep the same kind of data in one column, for example, if I have a column of integers, but there's some nans spread out throughout there, Pandas will switch all those integers to floats. That way it'll have float values throughout the entire column, because it can do that without changing the data in a material way. But sometimes there are mixed data types in a column. And in fact, I think we have a warning up here, right? Data type warning, columns 0, 1, 2, 3, 4, 7, 13, blah, blah, all these columns, lots and lots of columns, have mixed types, specify D-type option on import or set low memory equal to false, right? So Pandas is even saying to us, hey, I'm seeing problems with these columns. You might want to be careful about having mixed data types in here. So just to restate that, Pandas tries to keep the same kind of data type in each column, but however, you can have mixed data types like nans and strings in the same column. When I do df.dtypes, right? This is Pandas trying to show me the most common data type of a whole column.
Okay. Cool, thank you.
Mm-hmm. And it's truncating, but I'm not going to go and reset the display options right now. Good question. All right. Is .head something Python specific? Because it shows me an output, but not the same as .head. Let's take a look at it. Let's give it a shot. And to do this, let's just do df.head. Okay. This gives us the data frame output of the CSV that we read in, right? What if I just do df.head, but don't put parentheses on it? Gives me this. Actually, let me add the skip footer here. I think it'll make this a little bit cleaner. Wait for it. Oh, my histogram really got messed up. All these things are nans. I'll figure out what just happened here in a second. Well, let's answer this question, and then I'll come back and figure out what's going on there. All right. So this is giving us an output, but it's not a useful output, right? So bound method ndFrame.head of ID, member ID, settlement percentage, settlement term, et cetera, right? So this is trying to show us a text version of our data frame, right? So if I print df.head, right, here is something very similar to what we just saw, but without as much clutter. So if I change my Pandas display options. So this will actually show more rows and more columns. We'll be able to see a little bit more, right? Notice that this is similar to what our output was showing before, showing the first 5 rows, but printed out. I could also just say print the whole data frame. I got all kinds of stuff, right? So basically all that a data frame is it's called a 2-dimensional NumPy array. And that's not going to make a ton of sense. Let me give you an example. Right, so here's a list of values. Right. This is called a 1-dimensional list. 1-dimensional list is just a normal list of values, 1 through 9, or whatever it may be. It could be absolutely anything. That's in contrast to what's called a 2-dimensional list. With a 2-dimensional list, I can now begin to represent things in kind of a grid pattern. So what I'm going to do is I'm going to have a list of lists. So each individual component in this list is going to be itself another list. Right, so here's the first item in this list, the second item, the third item, the fourth item, the sixth, the fifth item, right? So you can see that this kind of a setup is now kind of has a grid pattern to it, right? So where each of these lists might represent a row of a data frame, right? So what we're actually using when we're using pandas and the underlying data structure, it's not actually a Python list. It's something called a NumPy ND array. It's very similar to a Python list, but it's much more complicated. All right, so let me get back to the original question, right? Is at any given time, I can access this underlying data structure and just print out all the text from it. Oh, you can't start variable names with a number in Python. Okay. So what we're seeing when we call df.head is we're seeing the raw text version of the data frame being printed out. That's the short answer. Probably the answer you wanted. When we call df.head with parentheses, we're actually calling a function which returns HTML, and that HTML gets rendered here by the notebook in this nice grid format with kind of the zebra stripes between the lines and the bolded header, and we've got the column index, right? Has all these different things. So to be clear, you will get a little bit of an output with df.head, but it's not correct. That's not a thing, so to speak, right? So you will still get something showing, but it's kind of just the plain text representation of the data frame. Put the parentheses on it to get it to actually render in its nice HTML form. It's probably a longer answer than you wanted, but we'll be talking a lot more about the grid representation of data frames as we move into linear algebra and other things like that in Sprint 3, right? So this is not all that far off in thinking about our data frames more like a 2-dimensional list. All right. So .head is not a Python thing. It's not a pandas thing either. Just always put the parentheses on it. Otherwise, you'll just get this really bad looking plain text version. Why, when importing the data set, this is the same question of the NANs, I just didn't archive it before, okay? Why do we have to import NumPy to look at the data type of NAN? That is a very good question. Because NAN, which stands for not a number, is a data type that is specific to NumPy and does not actually come with Python, right? So with Python, we have a few different what are called falsy values, right? So truthy, this funny word, it's a very weird word, means any values that when put in the conditions of an if statement evaluate to true. And then falsy means any values that when put in the conditions of an if statement evaluate to false. All right. So these are slightly more complex concepts than you might really need to know right now. But basically, Python has some default falsy, I don't know if it's with an EY or just a Y, or null values. The biggest one is called none, right? So Python null values versus np.nan. Navigating the hell of nans in Pythons, null and missing data in Python. Dealing with missing nans, working with missing data, et cetera, right? So why are we using nan as our null value indicator and not none? Right. So this is the main Python null value indicator. And this is the NumPy null value indicator. The short of it is that the pandas library is built on top of NumPy data structures, right? So where I mentioned that a data frame really under the hood are these two-dimensional NumPy arrays, and it's under the hood, pandas is already using NumPy. We haven't gotten down to that nitty-gritty level quite yet. And so using np.nan helps maintain consistency between the NumPy arrays that are already being used to make pandas data frames, whereas it has a second benefit as well, that np.nan has the data type of float, right? So take a look at this. Let's look at the data type of none, which is a none type object, versus the data type of np.nan, which is a float, which is a numeric object, right? So as we're preparing data for machine learning algorithms, many machine learning algorithms require numeric data throughout our whole data set, right? So the fact that a nan is numeric is going to allow some machine learning algorithms to be able to still process the data in the presence of nans. However, most machine learning algorithms can't handle nans either. We'll usually need to remove them completely from a data set before training a machine learning model. On that data set. All right. So let me sum up the answers, right? Lots of different reasons I just gave. First off, pandas is built on NumPy, so we're using the NumPy default value indicator rather than the Python null value indicator. Also, nans have a value, a numeric data type of float, which is valuable in a few different ways, but usually we don't want nans in there at all, right? Like there are other falsy values. For example, an empty string is falsy. False is falsy. An empty list is falsy. Any of these things in an if statement will evaluate to false. The integer 0 is falsy, right? So these things are similar in that when put in an if statement, they'll evaluate to false. But the most common and consistent null value indicator in Python is none, and for NumPy it's nan. So that probably introduced more confusion than it did offer clarity, and I'm aware of that. So part of what I want to do here with our Q&As is give you the vocabulary you need to go and explore these topics further, right? So explore the concept of truthiness and falsiness in Python. What is the difference between a none type object versus np.nan being a float, and how do those differ, right? So that's the very, very long and maybe not satisfying answer to why do we use np.nan instead of some other falsy value. We could use all kinds of falsy values when we are using pandas. You'll notice empty strings are falsy, meaning that's a null value. However, we already started our data set with all kinds of empty strings. Look at all these empty strings in here. Right? We had a whole bunch of null values in our data set as we read it in, but in order to maintain consistent data types and a numeric data type and consistency with NumPy, pandas changed all of those empty strings to nans for us. Right. So pandas is already trying to rectify some of these many different null value indicators, these different falsy values that could exist in a data set, and trying to land upon a common convention that we always use nans to represent missing data or to represent null values in a data frame. So it's already just trying to have more, that stronger consistency for us.
I have a follow-up question.
Mm-hmm.
First of all, that was really helpful. Thank you. But also, so in order to have a nan inner value set, do we have to import NumPy, or is it because pandas is built off of NumPy that we don't have to import it in order to have like a nan value inner data set?
Yeah, so we only need to import NumPy if I want to create new nan values. For example, I have all of these nan values by default in my data frame without having to do anything. This is just the behavior of read CSV, right? So I got all these nans for free, but in my function here, where I'm wanting to do a comparison, I've needed to return a single nan value or deal with nan values outside of a data frame. I've needed to import NumPy to be able to create new nan values. Now, in this example, I'm not exactly creating new values. I'm continuing nans that were already there. But most of the time, unless we are creating a new column, we want to make sure that certain values are set to nan, we won't ever really even have to import NumPy for the nan functionality. It just so happens that the use cases we're working with today require us to write functions that deal with nans. This data set actually has kind of a lot of missing values. So typically we'll import NumPy to do all kinds of other more interesting things than just have a null value indicator. So for now, like that's the one thing we're using NumPy for. In the future, we'll import NumPy to do 10 other things. And oh, by the way, it can also help us generate nan values. So in the future, NumPy will be much more relevant than just nan values. So
Okay, thank you.
yeah, I hope that's helpful. All right, I keep on getting this message when I'm creating a new column. The setting with copy warning. We talked about this a little bit. We'll talk about this in a minute. Q&As are optional. And then parameter vins versus pd.cut. We could take a look at this in just a minute. All right, so let me just talk one more time briefly about the setting with copy warning. There's actually a really good Stack Overflow post that I would point you to that has actually a lot better explanation than I could probably give here. So let me run this code in a way that will generate the settings with copy warning again. And then I'm going to copy and paste it into Google and to find that, that post. Or maybe I'll actually just copy it here. Yeah, I'll just copy it from here. All right. Ooh, DataQuest usually has really good articles. But this, I think, is the Stack Overflow post I meant. Look how many upvotes it has. Because this is a really common warning that pops up when you are making modifications to a portion of a data frame, whether it's a single column or a part of a column. This comes up all the time. And this person's giving some fairly detailed code so that people can understand what they're trying to do when this warning pops up. And this is what it says. The setting with copy warning was created to flag potentially confusing chained assignments, such as the following, which don't always work as expected, particularly when the first selection returns a copy. See some other GitHub things for background discussion. The warning offers a suggestion to rewrite as follows. However, this doesn't fit your usage. While it's clear that you don't care about writes making it back to the original frame since you overwrote the reference to it, maybe this portion isn't as good. Here's the one I think I really meant to read. In general, the point of the settings with copy warning is to show users, and especially new users, that they may be operating on a copy and not the original as they think. There are false positives. If you know what you're doing, it could be okay. One possibility is to simply turn off the default warning, as Garrett suggested. Where's Garrett's post? This is Garrett. So Garrett says, some people when using pandas get so annoyed by this warning that they just turn it off so that it doesn't even come on anymore. Because most of the time you know what you're doing and this warning is not super relevant. So a couple ways to get rid of it. Turn it off. A better way to get rid of it is doing what I did here, and is that make sure you're not operating on a copy of your data frame. And ironically, the way to make sure you're not operating on a copy of your data frame is to make another copy of it, right? So before I did any of my modifications here, I made a copy of my data frame. Oh, did that cell get moved? Did I accidentally delete the copy cell? Maybe that's why everything here is broken. Oh, I commented it out. That makes more sense. All right, histogram's back. All right, so I'll comment this line, make a new copy of the data frame to ensure that we're working with the data frame itself and not some silly copy of the data frame. This should take care of that's not the name of the warning. What's the name of the warning called? Setting with copy warning. So this is one way to handle it. Another way to handle it is to turn it off, as this Stack Overflow post mentions. A third way to handle it is to ignore it. Just ignore it and trust that if what you see, if the changes that you hope to be made to your data frame are being made the way that you would expect them to, then for now, I mean, it's only day 2, we can just ignore it until we get a bit better with pandas, a bit better with Python to really understand how Python references objects in its memory. And when it's referring to a reference to a memory address versus a direct pointer to a memory address. Anyway, we'll talk more about these things later on in the course, especially when we get to the computer science section of the course. You guys deal a lot more with pointers and passing by reference versus passing by value. There's a lot of other things that I would need to spend more time fully jumping into to really have this make a ton of sense. But for now, hopefully this gets you started. Okay. So ignore it, turn it off, or make a copy to get this error to go away. Well, not error, warning. Does the parameter bins and pd.cut do the same thing? Yes, I believe so. So the thing with pd.cut is that it has a specific behavior, right? So pd.cut allows me to bin a continuous variable into a certain number of bins, all right? The thing to know about these bins is that they all have the same range, meaning distance from the minimum value of that bin and the maximum value of that bin. So let's find an example here in our Lending Club data set. It needs to be something that's numeric. All right, so maybe we'll look at loan amount. All right, we'll look at loan amount. All right, so I'm going to do pd.cut, and here's the note. Here's the documentation, right? So you can see that we need some X value. This is the column that I want to segment into bins, and then the number of bins is the second parameter, right? So I want to do pd.cut on loan amount, and how many bins do you want to divide it up into? Let's divide it up into 3 bins for now. And then I'm going to give these bins some new labels. I'm going to call the first bin, bin 1, the second bin, bin 2, and the third bin, bin 3. And we're going to use this to make a new column on our data frame. Loan amount bins. That's what we're going to call this new column. All right. And then, see, these will all be string values. So let's run this, and we'll do a df.head and take a look at it. Actually, we'll just do a df loan amount and loan amount bins. Okay, so here's my different loan amounts, and here's the different bins that something fell into. Question is, how did pd.cut choose the value that is the dividing line between the bins? How did pd.cut choose the value that is the dividing line between bins? Well, what it did is it took the max value, subtracted the minimum value, and then divided that by the number of bins, right? So if I do this data frame dot describe, then my max is 40,000, and my min is 1,000, and then my different cutoff points were max minus min divided by 3. So this is loan max, loan min, loan max, loan min. Put these in parentheses to make sure the subtraction happens before the addition. And then, okay. So 13,000 is the size of a bin. So what does that mean? The bin 1 starts at 1,000 inclusive and ends at 14,000 exclusive. So anything that fell in this range went into bin 1. Anything that went into bin 2 started at 14,000 and ended at 27,000 exclusive. And then bin 3 was 27,000 to 40,000. I think that's still exclusive, right? So these are the intervals. In order to decide which data points went into which bins, right? So the thing I want to point out here is that the distance between the lower and upper bound of each bin is the same. Right? This is the hallmark of PD.cut, is that the way that it decides to bin things is, well, I just give it a number of bins. It looks at the smallest value and the largest value, picks 3 equal sized bins, equal sized in terms of distance from the smallest and largest value in that bin. However, I might get a different distribution of values into this bin, right? For example, if I make a histogram here, I'll try and hurry here and then I'll let you go, of loan amount. With 3 bins, here's my histogram. Right? Well, what if I did a value counts on the loan amount bins? What did I call it? I spelled out amount. All right. You'll notice that the proportion of the number of observations in each bin matches the histogram. Right? So this is essentially me proving to you that yes, the same way that the bins are chosen in our histogram is the same way that PD.cut slices and bins our data, right? So this starts at 1,000 and it ends, where does it end? Where does this bin 1 extend to? Well, it extends to 14,000. Then bin 2 starts at 14,000 and extends to 27,000. Bin 3 starts at 27,000 and extends to 40,000. Because PD.cut, this is the most important thing, PD.cut is not trying to retain the same number of observations per bin. PD.cut is trying to maintain the same like width of bins. And for lack of a better word, I'll just, that width is like the difference between the min and max value in each bin. Right. This is how PD.cut decides where the cutoff points are for the bins. Right. Now this lies in stark contrast to another binning tool called PD.qcut, which stands for quantile cut. And quantile cut does the opposite. It tries to maintain a consistent number of observations per bin by adjusting the min and max values per bin. All right, so if I do something like I'm going to Q cut this into 3 bins, and then I'm going to do value counts here. See if I did this right. Okay. I think I might have used that incorrectly. So I should get the same number of items in each bin. Okay, okay, this makes sense. So what I did is I divided this into 3 separate quantiles. So each group is the value from the smallest value to the 33rd percentile, 33.333. And then the second bin is from the 33rd.333 percentile to the 66.666 percentile. And then the third bin is from the 66.666 percentile to the 99.99999 percentile, right? So it tried to divide these into equal-sized bins based on their percentile ranking rather than just lopping them into bins based on where the values fell on these intervals. So this is not completely right what I have here. Quantile cut. Divides into bins based on percentiles and not min/max bin values. For example, if I change this to a 4 here, this will now divide it into quartiles. So here's the 4 different quartiles of loan amounts. Anyway, so that's PD.cut versus PD.QCut. Short answer is yes. Histograms do the same method as PD.cut. Those are 2 different ways of binning variables, taking continuous variables and turning them into categorical variables, which can be a great thing to do in preparing for something like a crosstab, right? After I have some continuous variable and I bin it, then I can use crosstabs more effectively to analyze the distribution. So, all right. That's a lot of stuff. I realize it got a little bit advanced in explanations and things like that. I hope this notebook and some of my explanations have been useful. At the very least, I hope that they have helped you understand more terminology or understand what to Google next to go further with these topics. We'll have another Q&A on Thursday. That Q&A will be much more focused towards preparation for the sprint challenge. We'll be talking more specifically about what will be on the sprint challenge and what you need to know. We can't test every single objective from the week in that 3-hour block on Friday morning. So I'll be pointing out to you what the most important things are to know for that sprint challenge a little bit later this week. So thanks, guys. Thanks for joining the Q&A. I hope this has been helpful. And I will see you tomorrow morning at the very latest for more Python and data wrangling, data munging. So thanks for being awesome. I'll see you guys tomorrow.